Welcome to another tutorial of Hydrology for Beginners. Today we will discuss how to derive flood hydrograph from unit hydrograph. Prerequisite to this presentation will be my lectures on unit hydrograph and some solved problems. So you may go to the YouTube video that I have already uploaded, and you can easily find it in the top right corner of the video screen. So please first go through it and then come back to this presentation. So this is flood hydrograph from unit hydrograph. So the problem is like this: the ordinates of a 6-hour unit hydrograph of a catchment is given below. So these are all the ordinates. This is the star hour, that means hour, and this is the, I think this is a unit hydrograph, so this will be your meter cubed per second discharge. As you know, unit hydrograph is known as the hydrograph for a rainfall or excess rainfall amount of 1 centimeter which has taken place for 6-hour duration. For in this case, generally d-hour unit hydrograph means 1 centimeter rainfall for d-hour duration, and the hydrograph generated due to that amount of excess rainfall, 1 centimeter. So I have already discussed about this. So these are the ordinates given. Now the question is, derive the flood hydrograph in the catchment due to the storm given below. And they have also given the durations of the storm. Duration of storm is 0 to 6 hours, then 6 to 12 hours, then 12 to 18 hours. 6-hour duration. And this 0, 3.5, 11, 16.5, they are all accumulated rainfall. They are all accumulated rainfall. That means from 0 to 6, 3.5 centimeter has taken place, centimeter of rainfall has taken place. Then from 6-hour to 12-hour duration, 11 centimeter per hour rainfall has taken place, including this 3.5. So for this 6 to 12-hour duration, the actual rainfall that has taken place is 11 minus 3.5. So it is coming around 7.5. And I think this is given in centimeter per hour. So what happens is, and after 12-hour to 18-hour, the accumulated rainfall is 16.5 hours. But the 3.5, that means 3.5 plus 11 plus the remaining amount of rainfall, which makes it 16.5. So how much? Let me calculate 16.5 minus 11. So it is coming at around 4.5. 4.5.5. So this is, yeah. So if I give it as 4.5, then it is coming, yeah, 4.5 centimeter per hour rainfall has taken place from 12 to 18-hour rainfall, and from 6 to 12-hour rainfall, 7.5 has taken place. Correct. So I think it will be not 4.5, but it will be 5.5 because 5.5. This will be 5.5 centimeter per hour rainfall, which has taken place from 12 to 18 hour duration. And from 6 to 12 hour duration, 11 minus 3.5, 7.5 centimeter per hour rainfall has taken place. Why this is the case? Because this 0, 3.5, 11, 16.5 are actually accumulated rainfall or cumulative rainfall. Okay. So this problem also will give you the loss rate, initial loss in with respect to phi index. So they have given it as 0.25 centimeter per hour. Okay, so the phi index is 0.25 centimeter per hour. So for 6 hour duration, 6 into 0.25 centimeter, because per hour it is losing 0.25 centimeter, and we have one storm for 6 hour duration. So it will come nearly 1.5 centimeter per hour. This is the loss, infiltration loss. Okay, and so what happened is the total rainfall after this 6 hour, 0 to 6. So total rainfall is given as 3.5. But as there is a loss of 1.5, so effective rainfall will be for the first 6 hour duration is what? 3.5 minus 1.5, that is 2. So 2 centimeter per hour is the effective rainfall that has taken place. And by effective rainfall means rainfall minus loss. So phi index represents the infiltration loss. And we know that this the duration of the storm is 6 hours. Now this your loss is 0.25 centimeter per hour. So in 6 hours you have 1.5 centimeter loss of water lost. So now this you can directly deduct from the actual rainfall or total rainfall. Okay, for the first 6 hours. For the first 6 hours, the total rainfall is 3.5. So if we deduct the initial loss from it, 3.5 minus 1.5, 2 centimeter per hour will be your effective rainfall. Okay. So similarly, when in the case of the 6 to 12 hour, from 6th hour to 12th hour duration, the rainfall has taken place, and this problem is giving you the total rainfall up to 12 hours. Correct. So we have to find out what is the amount of rainfall that has taken place from 6th hour to 12th hour duration. So that will be your 11 minus 3.5, 7.5 centimeter per hour. And again, due to this infiltration loss, which has also taken place in this 6 hour duration, because that is the way the problem is placed to you. So again, you will deduct 1.5 centimeter per hour from this 7.5 centimeter per hour. So for the second 6 hour duration, effective rainfall will be 6 centimeter per hour. So for the first 6 hour, it is 2 centimeter per hour. For the second 6 hour, it is 6 centimeter per hour. And then for the last 6 hours, 16.5 minus 11, amount of rainfall is 5.5. Again, you deduct minus 1.5 from it. You know why. So it is coming around 3 centimeters per hour. I think there's a mistake. Not 3, but 5.5 minus 1.5 is 4 centimeters per hour. So for this problem, from the first 6 hour duration rainfall, 2 centimeters is the effective rainfall. That means total rainfall or accumulated rainfall minus initial loss. Then from 6 hour to 12th hour duration, after deducting the initial loss, it is coming as 7.5 centimeter. Same 11 minus 3.5, So you get what rainfall has taken place within 7 to 12 hour duration, and after then what you will do is you just deduct 1.5 hours from 7.5, 1.5 from 7.5, and you will get the result or the effective rainfall of the second 6 hour duration. So it is coming around 6 centimeter per hour. So for the first 6 hour it is 2 centimeter per hour. For the second 6 hour it was 6 centimeter per hour. And for the third one, what happened? You have the effective rainfall is 5.5 minus 1.5, 4 centimeter. So for the last 6 hour we have 4 centimeter per hour rainfall. Now the thing is that the ordinance of 6 hour unit hydrograph over catchment is given below. Derive the flood hydrograph with the catchment due to the storm given below. Now you can note that we already have the 6 hour duration. We know that 3 consecutive 6 hour duration storm has taken place. And what are the effective rainfall after each 6 hours? First 6 hour, after first 6 hour, effective rainfall is only 2 centimeter per hour. For the second 6 hour, the effective rainfall is 6 centimeter per hour. And for the last one, the effective rainfall, that means accumulated rainfall minus initial loss, is 4 centimeter per hour. So our aim is to derive the flood hydrograph. So what we have to do, let me see. Okay, so they have also given some more data. They are saying that the base flow can be assumed to be 15 meter cube per second at the beginning and increasing by 2 meter cube per second for every 12 hours. So they are saying that for the first 0, base flow is 15 meter cube per second. Up to 12 hours, that is from here to here, it is only 2 meter cube per second, 15 meter cube per second. But after 12 hour duration, the base flow can increase by 2 meter cube per second. That means after 12 hours, from this to suppose 12 to 24, I can say. For 12 to 24 hour duration, we will have a base flow of 17 meter cube per second because it will increase by 2 meter cube per second every 12 hours. Okay, so for the first 12 hours, it was 15 meter cube per second base flow to be added to each of the ordinate of the unit hydrograph. But after doing something which I am coming on in the later slides, and then from 12 to 24 hours, 17 will be your place. 17 meter cube per second is your base flow, and so for every 12 hours, you have to increase the base flow by 2 meter cube per second. Your original or initial base flow is 15 meter cube per second. Okay, so now let me go to the next slide. So we have a scribble board here. So in this scribble board, my first thing will be I have to again write down the ordinates of the unit hydrograph of 6 hour duration, because that is the basic of this entire problem. So let me first write it down. So this problem is also taken from the famous book Engineering Hydrology by K. Subramanian. So you can find it on Amazon or Flipkart or any other standard book stored both online and offline. And the problem I am discussing about is given in the page 198. Okay, so let us first draw, or let us first write down the ordinates of the unit hydrograph. Okay, it is, remember, it is 6-hour unit hydrograph. So what you will do is you will first draw a table, and in the table the first column will be time. Time is the duration. So, and it will always, the storm will begin from 0, correct? And for every 3-hour duration, they are saying that data must be taken. Although this is compromised as per as our requirement. So here for every 3-hour duration, I am giving the graph, but the actual case may be different. So now the first column after time will be ordinate of the unit hydrograph. So this is 0, this is 25, 50, 85, 125, 160, 185. 125 is situated like this, 125, 160, and then 160, and then it is coming 185. After then it is the 21st hour. So for the 21st hour, as there is no data given, you see the ordinate of unit hydrograph was given from 0, 3 hour, 6 hour, 9 hour, 12 hour, 15 hour, 18 hour, 24 hours. So there is no data given for the 21st hours. Okay. So what we will do, we have to interpolate here, and after interpolation we have got 172.5. Okay, 172.5 meter cube per second. And in the last hour, that is the 24th hour, the ordinate is like 160. So for the first column after the time column, 160 is the 24th hour rainfall, they are saying. Okay. So it is more or less the ordinance of the unit hydrograph, although it is more lengthy. It has gone from 24th hour to 60-hour duration. Okay. Now here you see one thing is that the given data is 0, 3, 6, 9, 12, 15, 18, 21, 24. So all these are have a difference of 3 hours. Okay, but mostly the problems will come as 6 hours, and your data will also be given for 6 hours. So let me first go and solve this problem. This is a very good problem, an intelligent problem. So in case of, as we know that due to the linear invariance property of unit hydrograph, we can say that for 2 centimeter hydrograph, that means the DRH, direct runoff hydrograph, the ordinates will be 2 multiplied by the ordinates of unit hydrograph. So let me see whether it is right or wrong. Yes. So when I multiply 0 with 2 centimeter, it becomes 0. So in similar manner, 2 into 25 means 50, 50 into 100, 85 into 2 means 170, 125 means 250, 320, and this one is a little bit 370, right? And 21 ones are okay. So this is 370, and this column actually is giving you the ordinates of 2 centimeter DRH. DRH means direct runoff hydrograph. That means the runoff minus losses. So to get these ordinates of the DRH from the ordinates of the unit hydrograph, just multiply the amount of storm for which you are making this direct runoff hydrograph. So here it is 2 centimeters. So I'll deduct 2 centimeter with 0, 0, 2 centimeter 25, 0. So you can see this is the way it goes. Now for this ordinates of the 2 centimeter rainfall this is the ordinate due to the 6-hour duration rainfall of effective rainfall 2 centimeters, correct? Now this problem is considering two more effective rainfall. One is 6 centimeters DRH and another one is 4 centimeter DRH. But these two events that's taken place after 6 hours. This is after 6 hours, this is after 12 hours duration. So the first one may begin from 0th hour. So this is gone. Now the 2 centimeter DRH is the first storm that has taken place from the 0th hour. And this unit hydrograph is also the runoff of that storm from the 0th hour. So we cannot change this. Okay. So next one is lagged by 6 hours. Okay. So 0th hour not considered, 3rd hour not considered, 6th hour not considered. So this unit hydrograph will be lagged by this 18 hours and then we will be given the chance to defend our report. So the 6 centimeter DRH is due to the storm of 6 centimeter for 6 hour duration. So I am repeatedly telling this. So for this, just leave the first three places because there is 0th hour, 3rd hour and 6th hour. So you just lag the DRH of 2 centimeter, or rather the DRH, not the DRH, but the ordinates of unit hydrograph by 3 lakhs. That means it is basically by 6 hour duration. Okay, so you are lagging the unit hydrograph, the ordinates of unit hydrograph for 6 hour duration. But here you have given the time column. This is the time column, and where you have mentioned the time within 3 hour duration, 0, 3 hour, 6 hour, 9 hour, 12 hour. So that is why these things are there. So for the 6 centimeter rainfall of duration 6 hours, the resultant direct runoff hydrograph will be, or the ordinates of the direct runoff hydrograph will be, so we'll lag this by 0. We'll lag this unit hydrograph by 0. Note that. Not we'll lag the 2 centimeter hydrograph. We'll lag the original unit hydrograph. It is starting from 0. Then it is going for 25, 50, 85 and so on. So what we'll do, we'll write the 0 here after 3 spaces, 3 rows. 0th row, 3rd row and 6th row. So from the 4th row, we'll start to write the ordinates of unit hydrograph, but after multiplying it by 6 hours. Okay, so 6 hour monitoring, you can say, or 6 hour has been tested. So here what you do, you just lag the DRH for 6 hour duration, and the rainfall amount is 6 centimeter. Okay, correct. So when I multiply 6 with 0, it will come as 0. 6 with 25, it will come 150. 650, it will come 300. 685, it is coming 510, and so on. So here also, if it is required, you have to do some interpolation. If not, nothing can be done. So this is the way 6 hour duration, 6 centimeter TRH we have drawn. Now the last one, 12 centimeter rainfall, and we want to do it. We want to reduce the section by some means. The main motto is that they will develop some house there. So they have drawn the 6 hour unit hydrograph of 1 centimeter as 6 centimeter DRH. So we have also done that. We have also accept that. So we have left first 3 rows. From the 4th row, you start the this ordinates of unit hydrograph. 0 से start करो, खत्म करो, आखिर. Okay. So 2 centimeter for 6 hour gone, 6 centimeter for 6 hour gone. Now last one, 4 centimeter for 3 hours. That is also very gone. So 4 centimeter, again this ordinate of unit hydrograph will be there. Here we have 0 to 6, 6 to 7, but we do not have the 7 to that. Sorry, we have the 0 to 6 hour duration, then 6 to 12 hours, then 12 to 18 hours. Now we are beginning the 12 to 18 hour duration. What will be the DRH, direct runoff hydrograph? So we have deducted the initial loss from the accumulated rainfall and found that it is only 4 centimeter per hour. So what we will do is we will lag the original unit hydrographs, and it is lagging by 6 hour duration, but that is not an issue. So what is happening is that consecutive 3 storms taken place. One at the 0th hour, followed by another on 6th hour, and third one is 12th hour, and after them another one 18th hour. But at the time of awarding venues for cricket matches, what happens is that what we do is that we have the ordinates of unit hydrograph, we multiply it by the 2 centimeter DRH to get the ordinates of the 2 centimeter DRH. Then we multiply the unit hydrograph by 6 after lagging 6 hours, because 6 hours after that storms are coming. First storm is coming and come within the first 6 hours of the day. Second storm 6 to 12th hour of the day. Third storm is coming, and I want to take 12th hour to 18th hour duration. So the first 3 columns are not given. From the 4th row of this and the first row of unit hydrograph, now we will do it. So first is 6 into 0 is 0, 6 into 25 is 150, 6 into 50 is 300, 6 into 85 is nearly 510, and so on. Okay, so this is in our record, and which cannot be changed very easily. Now that this 12 hour rainfall is 6 hour rainfall is gone, first 6 hour rainfall, second 6 hour rainfall has gone, and third 6 hour rainfall has also gone. So what you will do is, you are doing everything based on these ordinates. These are all ordinates, not abstract. These are ordinates. So for the 2 centimeter rainfall, you have just multiplied 2 centimeter to all these ordinates, For 6 hour duration rainfall, you have left 3 rows because each row is carrying 3 hours, but still when I leave the 3 rows, it is saying, or it is depicting that you have left the first 2 hours of the tree, but it is actually not the case. It is the case of worshipping, and there what they do is that for scientific reasons, what they do is they lag this unit hydrograph by 6 hours and start the first ordinate from the next 6 hours. After multiplying the same with 6 centimeter rainfall. This is supposed to be taken place in the second 6 hour duration. So accordingly you multiply, okay. So 6 into 0 is 0, so 0. 6 into 25 is 150, yes. 6 into 50 is 300, 6 into this is 510, and so on. And lastly, to find the ordinates of the third storm, which is also have that duration of 6 hours. So we'll again do it. Now what happens is we'll relieve the first 6 rows of the table, because first 6 row means 0, 3rd, 6th, 9th and 12th. So within this first 6th, not exactly 6, it is 5th row, 5 rows will come up to 12 rows. So what the last hydrograph will do, relieve first one, second one, third one, 0, 3, 6, 9th one and 12th one and 18th one. This all 12 hour duration is relieved, given relieved to you. You have lagged your rainfall, through which you are converting the citizenship also. So you have lagged the last one by suppose 1, 2, 3, 4, 5, nearly 5. Not, I will not say hour, because 5 is not the hour. It is the hour that has been taken place by the different cars and different vehicles as a working hours. But it is not the case. So that is why after 0, 3, 6, 9, 12, at the row of 15th hour, they are suggesting that there is runoff. There is what he has said, Sushanta. So the thing is that after lagging the unit hydrograph by 6 hours, so actually it is coming 1, 2, 3, 4. If you just left the first 4 row, then you will get to drink the pure water or eat something pure. So the first 4 you leave, okay. From the 12th hour duration you can start, and you start with 0 because the unit hydrograph has the first ordinate as 0, and then just wait a little bit, because then what we'll do is, so here from this, so let me write the column again, because it is a little bit heavy. So let me write the column again. So the first column will be the time or the duration. Second column will be the ordinates of unit hydrograph. Okay, and the third one is ordinates of the 2 centimeter DRH. Ordinates of let's see. So one ordinate is given. Now for the 2 centimeter rainfall, another ordinate to be given, and another to be given after 6 centimeter rainfall takes place, and lastly 12 centimeter rainfall has taken place. So for the first, or to be precise, for the third column, the ordinates of the 2 centimeter DRH, let it be led by 6 hours first. Okay, 0 and 3 is enough because 6 hours like that. Secondly, or I would rather say it as third. Third is what they are saying is to, I think, another ordinate will be produced for the 12 centimeter rainfall. So what the competent authority is saying, the ordinate of 2 centimeter DRH will be added to the ordinate of 6 centimeter DRH and the ordinate of 12 centimeter DRH within 2 days. Okay, so he has asked you people to send the reports as early as possible, but this is the way it must be. So for the first unit hydrograph, that is 2 centimeter DRH, you reach X. Then for the 6 centimeter, you will reach X. Okay. So let us go into the next slide. So we have already found out the ordinates of 2 centimeter, ordinates of 6 centimeter, and ordinates of 12 centimeter. Correct? Remember, the first one, 2 centimeter, will start from the beginning of the rain. Second one will start after 6 hours, and third one will start after 12 hours. So let us go to the next one. So this is the gist of the solution. What is given? Effective rainfall that can be calculated from accumulated rainfall and storm loss, 5 index. And also given is the ordinates of that unit hydrograph. So how to solve it? Madam has already shown it. You can go and watch the tutorial, or you can have your patients hearing of this tutorial. Okay, so ER, or effective rainfall, is actually the what I would say that actually this is the way what happened is that, so we have the ERH of unit hydrograph, ERH of unit hydrograph. You just multiply with that peak rainfall, peak runoff, like 2 centimeter or 6 centimeter or 12 centimeter. Okay, if they are coming, they will vanish. Okay, so you're inventing, or rather reinventing, this ERH and design value. Okay, so now let us go to the next slide. Okay, so some process are there. What do you mean by flood hydrograph? What do you mean by unit hydrograph? What do you mean by baseflow, phi index, effective rainfall, accumulated rainfall? Okay, so we have already discussed about the way we should proceed to get the flood hydrograph from unit hydrograph. We have also drawn that the unit hydrograph we have drawn. We have also drawn that hydrograph we have drawn. And then also we have drawn the 2 storm hydrograph of 2 storms that has taken place just in the morning of the examination. So these are the what development we have. So what happened is, what we have done, we have added the ordinate of 2 centimeter rainfall into the depth of the lake. No issue. Now, before doing that, what they have done is they had added each of the ordinate of 2 centimeter rainfall unit hydrograph to the next one, that means the 6 centimeter rainfall unit hydrograph. Okay, so 2 centimeter and 6 centimeter is gone, and now you have now what I say that now you have left only you have the potential to the justice and yeah, effective rainfall. Page number 198 is what you are following. So what happens here from unit, let me again repeat this because it's a very interesting and very good development that we have. So our per unit hydrograph, what happens? Let me see. So there is some amount of rainfall. So I already discussed about that. So 2 centimeter rainfall. Okay. Then we will wait up to 6 hours for the next one, which will be a 6 centimeter rainfall event, and ultimately what happens is we have that 2 centimeter rainfall, we have that 6 centimeter rainfall. Now the last thing that we have is let me see, I think there's some problem here. So one is for 2 centimeter rainfall, another is for 6 centimeter rainfall, and another is for 4 centimeter rainfall. As you can recall, the rainfall depths were given, but accumulated rainfall depth was given. So for each of the 6 hours, we have to find out the rainfall amount, and then we have to deduct 1.5 as loss from the rainfall depth, and we get the effective rainfall. So in this way, we have get an effective rainfall of 2 centimeter, 6 centimeter, and 4 centimeter, and for all these, unit hydrograph will be generated. The only catch is that this hydrograph is for 2 centimeter rainfall, this is for 6 centimeter rainfall, and this is for 4 centimeter rainfall. So all of three is Hindu. So now we have to, before taking our punishment, let me say that the 2 centimeter DRH ordinate was added to 6 centimeter DRH ordinate and then to the 4. Okay, so after adding this, because you see this 2 centimeter rainfall begin at the same time as the rainfall has taken place. That means rainfall and runoff both have started at the same time. So for 2 centimeter rainfall, there is no requirement of dancing. But for the 6 centimeter rainfall, there are various imageries has passed through this 6 centimeter rainfall, and as a result, you are also allowed to give the exam. Similarly, 4 centimeter rainfall, and after then, what happens? X2, X6, and X4 all are added to get the XI symbol. Okay, so now I think it will be easy to find the hydrograph, right? So this must be a very easy chapter but we have studied this. So we have to first study the unit hydrograph and then solve the problem. This is what competent authority has suggested. Okay. So this is what it is. So here we have to conclude this presentation. So another thing is that I have told it earlier at the beginning of the slide. Now after adding this x2, x6 and x4, you have to add the baseflow part with this one. Because this one has come from, this xi has come from x2, x6 and x4, correct? So he is from Polish and he want to give you a case. Now it is up to you, but this is the situation here. Okay, so I think this was the question asked from us, and as you can see, I have given you the answer. So yes, I have given you the answer. Okay. Now so once you have added the baseflow with this xi, okay, so with this xi, we have to add the baseflow. So for the first 12 hours, they are saying xi plus 12. But after then, sorry, this is not xi plus 12. Let me explain a little bit more because it will be more clear to you then. So this is actually 4 into xi. This is the problematic group. So this 4 into xi is there. So the ordinates of 2 centimeter DRH added to ordinates of the 6 centimeter DRH and then added to the ordinates of 4 centimeter DRH to get the final DRH. And when we add the base flow to the ordinates of this final DRH, we get the ordinates of the hydrograph, stream flow hydrograph of that area. So, but this is the question, and I have demonstrated how to solve it. And remember, this 2 centimeter rainfall has taken place from the same time when run is occurring, rain is occurring. So this is same. This is, I don't know, because this has begin after 4 centimeter. What it said, after 6 hour duration. Okay, and the last one, this 4 centimeter one, has taken place only after 12 hour duration of the first. Okay, so this is what is the case, and when you add the ordinates of these 3 runoffs hydrograph, you get an ordinate xi, which is equals to the okay, so that is it. So after adding the ordinates of all the DRH, if you add the base flow with it, then it becomes the ordinates of flood hydrograph. And this is also the procedure or the way where you can convert unit hydrograph to DRH. Okay. So with this, I have stop the presentation. Thank you.